Talk by offering a bonus beer to whoever could guess where the next screenshot that I show comes from. But impressively, you guys drank all the beer. So instead, I'm going to offer you a high five. So whoever can guess where this comes from, maybe, gets GTA all the things. High five to you. You can find me after the talk. So indeed, it comes from the video game Grand Theft Auto. Today, I'm going to be talking to you guys about the Data IQ edition, Grand Theft Analytics. As mentioned, my name is Jori. I'm a data scientist. And I'm going to tell you the slightly sordid tale of how 3 data scientists became slightly overly involved in a crime prediction problem. So a little bit more seriously, crime is in some ways actually a quite serious social problem. It costs the UK alone over $200 billion in prevention, in terms of treatment and in terms of trying to figure out who has committed crimes. Moreover, despite those figures, we know surprisingly little about it. We don't know what drives crime. We don't know whether it's going up or down. We're not even particularly good at saying where it's going to occur or how we should be preventing it. So, as well as being a social challenge, one of the problems here is that it's really also a technical challenge. So a lot of the traditional analyses that people have done are quite interesting. They can try and pull apart small features about what drives crime, but most of those have been done on small data sets. They've been done with really traditional analytics, and often with a small number of predictors. And so they can only do so much in trying to address the problem. So you could imagine an obvious solution to this is quote unquote data-driven crime prediction. Let's use big data. People have started doing this, and it's super cool. There's some really interesting work looking at Twitter data to predict where crimes are going to come next. But one of the problems with this approach, in part because it's quite new, is that people are not using very targeted techniques. So we're sort of on 2 ends of the spectrum of criminology, which does these really cool things on very small data, and big data, which is doing a lot with a lot of data, but not really very thoughtfully about what the actual problem is. So the goal of our project was to use all open source data, so you guys could go find all of this data and play around with it. And we want to leverage some of the more specific things that are true in this project. So crime has this really interesting feature of that it exists both across geography, so certain neighborhoods are more likely to have crime than others, and across time. There's different points in time, of day, of week, of year, that are likely to have criminal activity. So we're going to try and pull apart all of these different features and see if we can use that to predict crime. So what got us on this problem to begin with? Really, it was a financial challenge. So the National Institute of Justice in the United States recently released a crime, or rather a data challenge, in which they said, we're going to give you a bunch of free criminology data from the city of Portland, Oregon in the United States, and you can do whatever you want to predict where crime is going to come. We're going to take your model, we're going to take your predictions, we're going to look at where crime actually occurs in the next couple of months, and then we'll give whoever predicted crime best a lot of money. So there were 3 different categories you could compete in: street crimes, burglary, and motor vehicle theft. Another high five to the person who can guess which category we went for. All right. So we decided we would go for the challenge. Worth noting that our company icon is a bird, so this seemed particularly appropriate. So what did we actually do? So I said that we had open source data. And by that, I mean we found as much data as we possibly could. Like I said, one of the problems with crime analysis up till now is that people have used only a little set of data with only a few predictors. So we took the past crime data, which is what the NIJ gave us to begin with. That was the core set, so we could look at when and where crimes occurred over the last 5 years. And then on top of that, we grabbed a bunch of data. We took data from newspapers and magazines that flagged events. So we had concerts, we had political events. So these were points in time of things that we thought might be interesting. We took weather data. So we had weather data from the last 5 years across the geographical region of interest. We got the police precincts, so we could ask whether or not, depending on which police region the city was in, that affected the way that crime was occurring. We got points of interest from OpenStreetMaps. This is a super cool database if you guys are doing anything with geographic data. So it takes a map that looks a lot like Google Maps, and on it are tagged all sorts of points of interest. It has things from post office boxes to bus stops to movie theaters to restaurants. So you can get a much richer picture of the sort of social infrastructure of a city. We added to that social media data. So we took Foursquare check-ins. Foursquare is a social media app where people will go to a place and tell you that they had been there. So we had a really good sense of how people were using these different points of interest, when people were going there, how many people were going there, and how long they stayed. And then finally to that, we added US Census data. So the US takes census kind of depending on the level every year to every 4 years. And it's an insanely large data set. It's over 20,000 features that collects everything from the demographic information of a household, so the age, gender, race of someone, to information about their education, their income, the number of cars they have, the number of bathrooms they have. So you get a surprisingly detailed snapshot of who is living in a neighborhood and how they're living. So all of this data was a good start, but one of the main challenges in this project was to think about, well, how do you combine it together? Because we're trying to leverage all of these different features. We have some things like events that only exist in time, or the weather. This is going to change quite rapidly in time, but we don't have the resolution to say what's happening in West Portland versus East Portland. And in contrast, we had some features that were only geographical. Points of interest are relatively stable over time, and the data we had was only from a snapshot of the last year. So we took a series of different techniques. I'm happy to talk more about these afterward. But one was to do time series analysis. So Facebook recently released another open source package called Prophet, which does a really interesting implementation of time series. So the idea behind time series is you say, all right, let's look at what happened in the past and see if we can pull apart any patterns. Do things happen on the scale of weeks, on the scale of years, maybe on the scale of months in between? And then can we combine those curves back together to guess what's going to happen in the future? So we did that for all of our data that was time-based. Then we used a totally different technique for our spatial data. One of the challenges with our spatial data is that it only existed at very specific points. So I could say there's a movie theater here and a movie theater there, but we didn't know very much about what the effect of those movie theaters were on the space in between. So we did a technique that's called kriging. And what's really cool about kriging is that you can take all of these punctate points and you can build a continuous map. So we could say, okay, what's the effect of movie theater-ness or bus stop-ness across the entire space? So you could look at a place that had no bus stops or no movie theaters, but make a guess and say, okay, this is like a 10% movie theater-ish kind of place. And so you could start to build a much richer picture of what a geographical area looked like, even if you didn't have any specific data about it. Finally, for our census data, we had to figure out some way of taking those 20,000 features and reduce them down. So we did a couple of different approaches to dimensionality reduction. So we were able to say, sort of what are the overall drifts of things? It tends to be the case that a lot of variables go together. Maybe the number of cars you have tends to correlate with how big your garage is, or the number of toilets you have tends to correlate with the number of kids you have. And so you can start to build a picture of what are the things that really matter in this data? Where's all the change happening? So from that, we were able to build a bunch of different data sets that were starting to look a little bit more like each other. We had geography by crime, we had time by weather, we had police data, we had points of interest in this continuous way, points of use, and also the census data. So on top of this, we're able to do something that now put it all together in a single data set, which is called geohashing. So geohashing is really a super simple concept. You just drop a grid on top of a map, and you average everything that happens inside that grid. And you can make those grids smaller or bigger, depending on how fine-grained you'd like to predict. The main thing that's tricky about this is it takes a really long time, and so you have to be a little bit clever about how you do it. There's a couple of different databases. So Postgres has a super cool geographical platform built in called PostGIS. And if you're interested in doing anything with this kind of data, I highly recommend checking it out. It's a really friendly way of starting to play with geographical data at this scale. Then we were able to take our geographic data and we were able to index it by time. So now you can think we took a map, we gridded it up, and then for each one of those grids, we had all the information about how that grid changed over the last 5 years. So it was a huge data set, but we were able to put together all of these really different kinds of data. So it looked something like this, just a data table, which was a little too large to show on a slide here, but you can get a sense. From that, we were doing some interesting machine learning. So we could say, of all of these features we built, were we able to predict where crime was going to occur? From that, we built a map. And from that, we won a lot of money. So let me tell you a little bit more about what that means. So here's the map of what we predicted. So one thing that you could see is that here, there was actually a clear center of where a lot of crime was occurring. So this is what we predicted. And in fact, if you look, it's a little bit hard to see on this graph, but if you see where the actual contours are, that's where the crime really occurred. So you can see we did a pretty good job of capturing that hotspot. And it suggests that at least for this kind of crime, there's really a center point where people should be focusing their efforts, or maybe avoid parking their cars. The final question that we were really interested in, even though it wasn't that relevant for the contest, is asking what's actually happening? Why are these kinds of things driving criminal activity? And there were a couple things we found that I think are quite interesting, and are the sort of things that you might then want to make recommendation for policy changes. So one of the things we found is that the more retail stores there are in a region, the less car theft. So places where there's lots of handbag shops and hat shops, fine, your car's not going to get stolen. Similarly, places where people played with social media a lot, where they liked to check in, again, that's not where the cars were getting stolen from. So it's not the case that high-use areas seem to be where cars are being stolen from. In fact, it's the opposite. It's the places where there's not a lot of retail, there's not that many people. What we did find is that there were a lot of social factors that seemed to drive increased crime. So we found that neighborhoods in which there were a lot of transient populations, so families who weren't getting social support, families who weren't integrated in terms of having English as a native language, or families who themselves didn't have cars, were the kinds of neighborhoods where these crimes were occurring, which suggests that rather than high-end retail stores where a lot of social support is actually needed, is in some of the communities that aren't getting those kinds of resources to begin with. And so from our perspective, looking at some of the literature, this is a lot of what actually is being found in criminology. And it's kind of cool to see that big data is starting to be able to talk in a world where we can make specific policy recommendations and maybe change the way that some of the policing is being done at a relatively specific level. So on that note, thank you guys very much. Happy to take any questions.
Very well done, thank you very much. My question is that instead of combining all these different data sources, couldn't you just look at the records of the past crime, like crimes over the past few years, and produce a heat map? Wouldn't be as accurate as what you have produced?
It's an excellent question. So the question couldn't you just use past crime to model future crime? And so that was actually one of the baselines we had that we compared whether we did better than. And this approach was much better at predicting crime than just modeling past crime. But it was the case that the past crime made a big difference. So if we didn't include past crime at all, our model did less well. So it's definitely helpful, but it doesn't explain everything that's happening.
Yes, yeah. Can you go into more detail about what machine learning models you use?
Yeah, absolutely. The question was, what machine learning models did we use? So the model that performed the best was a random forest model. We actually tried a handful of different models. So we looked at, I believe, regression, we looked at random forest, we looked at XGBoost, and then we did a couple of ensemble models across those as well. And random forest overall had the best performance. So one thing that's interesting about this project that was a little bit tricky is we had to be careful about how we were validating our model. Because when you normally validate, you just do cross-fold validation, right? You take a handful of your data to train your model, you take another handful to test, you see how well you did. But if you do that with data that has a timestamp on it, you might accidentally use the future to predict the past. So when you do your cross-fold validation, you always have to choose to train on past data and predict on future data. So it was kind of an interesting challenge to figure out how do we best validate all of these very heterogeneous models. But on our sort of sliding window cross-validation, random forest way outperformed the rest of them. Plus we got some interesting information about variable importance, which was cool for interpretation.
Thanks. Last question.
Thank you very much for the talk. I actually have 2 questions. The first is, sorry about that. The first is that, do you feel that this sort of predictive models will be generalizable to jurisdictions where there is already a very low crime rate and crimes are essentially crimes of opportunity or passion? I come from Singapore, so that's one thing that I'm interested in. And second of all, do you foresee how your models can be used in, could you elaborate on the ways you see your models could be used in augmenting operations? Because I would imagine that police officers in a crime-ridden jurisdiction will already have some degree of domain knowledge or familiarity with areas that are prone to crime. So how does the model sort of like augment these sort of existing operations? Thank you.
Yeah, so the first question was, how well does the model generalize, for example, to cities or countries that have really different crime profiles, like Singapore, where it's a very low crime area? And it's a great question. We don't know. Hopefully it's the case that because we looked at so many different factors that at least things that are similar or things that correlate with those generalize, but it's one of the things we're really interested in is taking this model and looking at not only other kinds of cities, but also other kinds of crimes. So we did really well at predicting car theft. Would we actually do as well at predicting burglary? Not clear. So it's a super interesting question, and I think it's something that we need more data to really play with. Second question was, what? Oh, you don't remember either.
What I meant was, if police officers operate in a
Oh yeah, how could we use this functionally?
Because they really do know, like, perhaps a specific area highlighted in red was a very crime-prone jurisdiction. So they would naturally have deployed more resources to that area. So is that really something that the police department doesn't already know, or yeah?
It's an excellent question. So one thing that I didn't get to it at all, just for time, is that we actually predicted on a bunch of different time scales. So you can make prediction over a relatively large period of time, like a month, but you could also do it even on the scale of days. And the model worked pretty well for both of those. And so certainly on the scale of days, that's helpful, right? The police probably don't know in particular that this day is going to be a high crime day, that maybe there should be more resources deployed. But for me, I think the application that is much more interesting is trying to dig a little bit deeper into the model and saying, well, what are the features of this area that are supporting criminal activity? And can we go in and intervene on those? And I think that's a really hard question, and one that if we can start addressing it at that level, then it's much more effective at getting rid of crime than putting more police out that particular night anyway. And the guys that I've talked to at the National Institute of Justice, I think, are interested in kind of at some point taking that spin rather than just using it to deploy more forces on a particular place. So I think it's a great question. All right, thank you guys very much.
Thank you.